This is Geometry, Chapter 1, Section 4, in which we will discuss angle measures. And we're going to have to do a little build-up work to get to talking about angles. First, we need to know what rays are. All a ray is part of a line. It has one endpoint, but then it goes forever beyond in the opposite direction away from that point. The way we name a ray is to name the endpoint first and then name some other point that's on that ray. So we have a convenient ray right here. The end of it is A, so we'll name A first. We can name this ray AB with the word ray, or the ray symbol, which is just an arrow with one arrowhead on it. Or ray AC, because C is also on that ray, ray AC. Notice the endpoint is first. It says start at A and go through C. Now if two rays make a straight line together, and they have the same endpoint, like this, K, then we call those opposite rays. So ray KJ and ray KL are opposite rays. Now an angle happens when you get two non-collinear rays sharing an endpoint, such as this beauty right over here. You get two different rays. They have the same endpoint at Z. And they don't make a straight line. The two rays we call the sides of the angle. And that turning point, that common end point, is called the vertex. So given this angle, let's see if we can name the sides of it and name the vertex. Remember, the sides are the two rays. And those should have ray symbols on them, so we will put them really quickly. There. Now we're good. So the two sides are ray ZX and ray ZY. And the vertex is that common point Z. When we name an angle, we name it using the vertex. So we can call this angle angle Z. If there are multiple angles there, such as if I drew another ray over here, like that. Now there's several different angles. There's three angles, one small one here, one small one here, and then one big one. Then we have to clarify which angle we're talking about. So you have to name points on each side. So this would be angle XZY or angle YZX. When you have to name it with three letters, you name the vertex in the middle. We'll get that ray out of there because we don't need it. When you have an angle, it splits the plane into three parts. You have the interior of the angle, the part that's inside it. You have the exterior of the angle, the part that's outside it. Okay. And then you have on the angle if it happens to lie on one of those lines. Okay. So let's use some of these terms and see what we can do with them. They want us to name all the angles that have B as a vertex. Here's B. We have one angle here, ABD. And we have another angle, DB, and we can name any of these points along it. I went with the closest one, DBC. But you could also call it DBK or DBF, or you could go the other order. You could go FBD if you wanted to, as long as B is the middle. What are the sides of angle ECK? That would be the two rays, ray CE and ray CK. And then they want us to name a point interior of angle JCF. So we need a point that's on the interior of this. Some people look and say K because K is inside that line, but K, remember, is this point on the line. The only one that's interior to it is H. If they ask for a point exterior, we could pick on A, B, D, or E. If they ask for a point on, then we could pick on F, K, C, G, or J. Would be on the angle. The way we measure angles in geometry is with degrees. And there are three primary types of angles. Acute angles, which are less than 90. I always remember it as, oh, that's such a cute little angle, because it's less than 90. Right angles are exactly 90. And then obtuse angles, it's the biggest word, so it's the biggest angle, bigger than 90. You don't have to use my little memory tricks, but that's what helped me get through. If we have two angles that have the same measure, they're the same number of degrees, then we call them congruent. Just like we said, segments that were the same length are congruent. If the angles are the same size, they're congruent. And on a diagram, we mark them, but we don't mark them with tick marks through, like we did segments. We mark them with arcs. So angle 1 would be congruent to angle 2. That's another way to name angles. If they number them like that, you can just refer to it as that number. And then similar to when we talked about segment bisectors as being something that cuts the segment in half, an angle bisector is something that cuts an angle into two equal parts. So they're going to give us some information here. We've got this beautiful picture. KM and KJ are opposite rays, which makes that a straight line. KN bisects this big angle. If we know JKN has a value of 5y plus 2, and we know JKL has a value of 9y plus 15, then our job is to find JKL. Well, if this is a bisector, that means this piece over here is half of the total. Or another way to say it is double this angle. 2 times this one would equal the big angle. Well, we have values for those things. JKN is 5y plus 2. JKL is 9y plus 15. We know how to deal with this, distribute, and then we can solve this equation. Subtract the 9y, subtract the 4, and we get y equals 11. And by now we know not to just stop at y equals 11. They ask us for JKL. So we need to plug into here. JKL is 9 times 11 plus 15. 99 plus 15 is 114. So we worked with angles and angle bisectors and raise. And hopefully, as always, if you had questions, you jotted those down. You've got your handy note sheet there. Bring those questions in, and we will see you in class.